Hello guys, welcome back to the new video. In this video, we are going to start the topic of trigonometry in GCSE math. So I'll be explaining the topic of trigonometry and explaining some different questions that are like past paper questions and exam style questions that are expected to be in your upcoming exam. So starting with the trigonometry here. Trigonometry, what is the trigonometry? Trigonometry is the study of how angles of a triangle relate to the length of its sides. So it means there is a trigonometry, a name suggests a trigno. From a tri means a three sides. So from that thing we know it's from a triangle. So we are studying how the angles of a triangle relate to the length of its sides. It means the angles and sides are already related to each other. So if we use one angle and one side, we can find out the other side or the other remaining angle as well. But there is a strict rule that every trigonometric function is based on a right angle triangle. It means there should be a right angle triangle. It means one angle should be 90 degrees, so then it would be applied. Like you can apply the trigonometric rules and find out the different sides. So I've already drawn a right angle triangle. We know in a right angle triangle, one angle should be 90 degrees. So if the one angle is 90 degrees, the other angles can be any angles. They can be different angles. To solve this one out, we should know one thing very important. The opposite side, the side opposite to the 90 degree is the always hypotenuse. So that's an hypotenuse. To find out the two different sides like the height or you can say the adjacent, we have to first of all figure out any angle. We have been given ABC triangle. You can say the remaining angle here, C. We say that angle is a theta, angle theta. So to get the hypotenuse, we have already the hypotenuse. To get the opposite, we should know the angle that you are considering. The angle we are considering is theta. So the opposite side to that is always named as opposite. And the remaining side now would be adjacent over here. So that's how we know opposite, adjacent and hypotenuse of the three triangles of this triangle. So to remember, that's a very important part, how to get the opposite and adjacent in a right angle triangle. Some people confuse with that, and therefore they got like somewhere they got this one as an adjacent and the other one as an opposite, and if they find the angles, that would be the wrong angle. So therefore you should know the opposite side, the angle that you're considering, the side opposite to that is always the opposite. Now to solve the questions, we have three basic things, three basic formulas. We know that is sine, cos and tan. One is the sine, the second one is cos, and there was a tan. These three are we are having the trigonometric ratios, and to find this out, we say sine of any angle theta should be equals to the opposite divided by the hypotenuse. That's one thing. Similarly for the cos theta, that's a small change in the formula, that is going to be now adjacent divided by hypotenuse. Hypotenuse should be in the denominator, and the last one for the tan, it's small change again. So now it becomes opposite divided by adjacent. That are the three formulas for these sine, cos and tan. And there's an interesting memory to trick them as well, to basically learn them as well, that we use SOH CAH TOA, SOH for so, then CAH for ka, and then TOA for toe. So SOH CAH TOA means sine equals to opposite by hypotenuse, cos equals to adjacent by hypotenuse, and toe from tan equals to opposite by hypotenuse or opposite by adjacent. So that's a memory trick. If you understand that, you'll be easily, like there would be nothing to like remember the formula or learn the formula. You can just from this trick you can take the formulas down. Now this is basically the basic things. We know the formula from SOH CAH TOA, and then sine, cos and tan formulas. We are given the hypotenuse and like the triangle. Now we'll be moving towards the different question. I'll explain how to solve with the past paper questions and exam style questions. Question number 1. We can see the question is given that use the trigonometry to work out the value of x. So we'll first of all take it out. What are we finding out? We are finding this side x. So we can see here, this is again a right angle triangle. This is the 90 degrees, and this is an angle theta given over here, 24 degrees. We know theta is equals to 24 degrees. And as I told you that we have the opposite side, the side opposite to the 90 degrees is always the hypotenuse. We have been given the largest side, that's in hypotenuse. Now to use the solving tricks, we know the formula, all the formulas I told you in sine, cos and tan, all the three formulas. We have to figure it out which two sides we have been given and which side we are finding out. So we know the angle here is 24. We are considering the opposite side to that, which is x. So it means this x is gonna be opposite over here. Now if that's an opposite and hypotenuse is given, the formula says that sine uses the opposite and hypotenuse, both of them together in one formula. So we have to use this sine, so then we can find out the opposite through that. Now to solve this out, we are using sine. We know from that sine of angle theta is equals to opposite by hypotenuse. That's the formula. Now using the formula, we have been given theta angle, so sine of 24 degrees is equals to opposite, that's an x, so we can use x in terms of opposite and divide by hypotenuse, that is 31. Now to solve this question, just we'll be doing here is we are taking this 31 to the other side and multiplying there with the x. And if we multiply there with the x, so sine of 24 degrees times by 31 equals to x. And we know already x is basically the opposite. You can use your calculator for that and multiply this. So sine of 24 times by 31. And when you multiply it, you'll get the final answer as 12.60. And you can say 6, not 0. When you take it out on like 2 decimal places, it would be 61 after rounding it off, with the centimeters as a constant unit. So that would be your solution for this question by finding out. It means the opposite over here is 12.61 centimeters. That's how you have to solve the question. Moving to the second one, they have given ABC is a right angle triangle. ABC is a right angle triangle. Again, we know that side AB is given, that's a 7 centimeter, and side BC is given, that's a 4 centimeter. What we are finding out is find the size of angle CAB. It means now you see the angle we are finding out is over here on the above top of that. As we are finding the angle on the top, now the theta over here is going to be this one. To find the angle, we know again we have to use sine, cos and tan. So we have to first of all figure it out which two sides are given. You can see this opposite side is should be, we know that the angle theta is considering on the top now. So the side opposite to that would be 4 centimeter. It means now the opposite is below. And this one remaining side would be the adjacent. We have got two things, opposite and adjacent. We know the side opposite to the 90 degrees hypotenuse, and that was like the hypotenuse. We are not given that and we don't even want that. So to solve this, we know the formula says TOA. From TOA, we know tan is equals to opposite by adjacent. So we are given here is opposite and adjacent, and we are finding out the angle theta. So using that, we know it's a tan of angle here. Tan of angle theta, and theta we are finding out. So tan of theta is equals to opposite. We know the opposite is 4 by looking out the angle. So that's a 4 dividing by 7 over here. So 4 divided by 7. And we told that when we finding out the theta, what we have to do is we have to take the tan to the other side. So theta only remains. And moving tan, sine or cos to the other side, remember a very important part that it converts to inverse of that. It doesn't divide, it doesn't multiply, it converts to tan inverse of 4 divided by 7. Now at last moment you have to just use your calculator and it would be tan inverse of 4 divided by 7. After dividing this one out, you'll be getting the theta equals to 29.74, and we are getting it to the 2 decimal places, so we'll just leave it here, degrees. That is the solution for the angle. So it means the angle CAB is going to be 29.74 degrees. Moving to the question number 3, it says DEF is another right angle triangle and DE is 5 centimeter. We are given a DEF, an angle here is that is a 60 degrees and 60 degrees, as well as it is a right angle triangle. DEF triangle is a right angle and DE is 5 centimeters given. Working out the length of DF, we know we are working out this longer length over here, DF, which is, we know the opposite of 90 degree, that's a hypotenuse here. So to solve that, we are given the included angle, that's theta 60 over here, and we are given this side. Now what should be this 5 side? We have to be careful about that, because we know the theta opposite side to the theta is this EF, so that would be the opposite, and the remaining here would be adjacent. This one would be the adjacent. So now we know the adjacent is given, hypotenuse we are finding out, so we have to use that type of trigonometric ratios in that adjacent and hypotenuse both are coming. So we know this is going to be a cos, because cos says that's going to be adjacent over hypotenuse. Now to solve that, cos of theta angle is here. So theta is 60 degrees, using this one out as cos of 60 degrees equals to adjacent. We are given the adjacent, so that's 5 centimeter divided by the side df. We know hypotenuse is df, so you'll use df over here. To solve this thing, we have to just take this df to the above into the numerator and then take this cos 60 down and divide there. So it would be df is equals to 5 divided by cos of 60. Remember, it's not now going to be inverse of that, because this cos 60 is already with the angle. When you're taking only cos without the angle, then you have to make it to the inverse. Right now it's going like that with the angle, so therefore you have to divide it with the normal steps. Now solving with here on to the calculator, you'll be getting the answer for that as 5 divided by cos of 60. The answer for that as def equals to 10 centimeters. Yes, it's a centimeters because the unit here is centimeters. So that would be your df side. So you should know how to use this one out. Moving to the question number 4, that's again an important one. They have given use trigonometry to work out the value of x. You're working out again the value of x here using trigonometry. You have to see the included angle theta here is simply this, and it's a right angle triangle as well. We are given this 21. You should know this is a hypotenuse. Solving outside means this angle is this, so the opposite side to that is x. It means this is the opposite. We know opposite and hypotenuse, we are using these both. So then for solving this, we have to just use the sine of that. Sine theta equals to, the angle equals to opposite divided by hypotenuse. And now solving this one out, we are given theta, so sine of angle theta, that's 40 degrees equals to opposite again, which is going to be x divided by hypotenuse, that is 21. To solve this question, just take 21 to the other side and multiply there. So sine of 40 degrees multiplied by 21 is equals to x. Using your calculator here, sine of 40 times by 21, we'll be getting the answer here is x is equals to 13.49, and if you take it to the two decimal places, it's going to be 49, and it would make it a 50 total of that, with the x equals to 13.50, which would be the centimeter again because that's a side, and this would be the solution. Moving to another question, that is a past paper question again, question number 5. That's a very important question. The diagram shows a quadrilateral ABCD. We have been given a quadrilateral ABCD. CD is length, one of the length is given, which is 10 centimeters here. Then DB is given, which is 12 meters here. After that, we have been given the angle DBA. DBA, that's a 90 degrees angle. We have to get this thing. Now angle CDB again given is 56 degrees. And again another angle ADB is 34 degrees. The angles are given. We are calculating the length of AB. We can see the length AB is on this side here. This is the length AB. To calculate that, again we know this is a right angle triangle. We can consider this triangle ABD, and that would be ABD here, which is a right angle triangle. That would be 34 degrees. And we know the one side is given, which is 12 over here. 12 meter is given. And we are calculating the opposite side. We can see if this is a 34 degrees angle, the included angle, the side opposite to that would be the opposite. And the given side here would be the adjacent, because that's the remaining side. And this one would be the hypotenuse. To solve that, we should know that we'll be solving it again using, what should we solve? We know the opposite and adjacent are the two things given. So that includes the formula of the tan. Tan of the angle theta is equals to opposite by adjacent. In that thing, what we are finding out? We are finding out the opposite, which is the AB. So we'll just put the values here. Tan of angle theta would be 34 degrees. Tan of 34 degrees equals to opposite, we can say, is the length of AB divided by adjacent. And adjacent over here is 12 meters. Now what we'll be doing here is we'll be just solving it for the AB, taking this 12 to the other side and multiplying with the tan of 34. So tan of 34 degrees times by 12, that equals AB, length of AB. So while you can use your calculator, tan of 34 degrees times by 12. After timesing this all, what we'll get here is AB is equals to 8.09 meters, and we can just give it to two decimal places, so that would be your answer for the AB. Moving to the part B, calculate the area of quadrilateral ABCD. We have been given a quadrilateral over here, that is ABCD. We have to calculate the areas. To calculate that, we cannot get it directly, therefore we have to see there are two different triangles. We can do it the area of the first triangle and then the area of the another one, and we add them both, we'll get the answer for the area of the quadrilateral. To get the area of this ABD, we can just take it like this. We can simply see that the base over here is the 12. We can say the area for that is, area of triangle formula we use is 1 by 2 times base times height. To see that, we have been known that this right angle triangle shows 1 by 2 times by the base is 12 and the height here is AB, that we have already got in the part A, 8.09. so times by here, times by 8.09. when you time this all, you'll be getting the answer for the area of the ABD, which would here would be 0.5, because 1 by 2 is 0.5 times by 12 times by 8.09. Now when we time this all, what we'll get here is 48.54 with the meters square with the formula. Now the area for, we can write here is area of triangle, what was that, ABD. Triangle ABD equals 48.54 meters square. We have already calculated above. Now if we check the other one, the other triangle, what we'll see here, the base here is again 12. We can see here the base is 12, but the height is always the perpendicular height through the base to the other corner. It means the height over here should be this one, from the base to the other vertices of the triangle. If we get that, we to see again when we make it a perpendicular height, it means there would be a 90 degrees angle. And if there's a 90 degrees angle, we have been given one angle which is 56 and one of this length which is 10 meters. We know this 10 meters over here given is the hypotenuse, and the side or the what we are finding out, we are basically finding out the side that is opposite to that. So the angle is 56, opposite side is C and going towards the point here. So for finding this one out, we are going to find opposite. Again, using opposite and hypotenuse are given, it means we have to use sine, because sine formula says that sine of angle theta equals to opposite by hypotenuse. They include opposite, hypotenuse and the sine angle. We have been given hypotenuse as well as the angle, so we can directly apply to get the opposite over here. So now for that height, we'll be applying here is sine of angle theta equals to opposite by hypotenuse. Hypotenuse over there was 10 meters and angle is 56. So sine of 56 degrees equals to opposite by hypotenuse. And this opposite is basically the height of the triangle, okay? That's the height of triangle. To solve this now, taking the hypotenuse to the other side, we know that's a 10. So sine of 56 degrees times by 10, that is a hypotenuse, equals to the height of the triangle. So we'll write just height for that. To solve that, simply multiplying here, sine of 56 times by 10. After timesing it out, we got here is 8.290 equals to height. That would be in meters. Now we got the height, but that's not the final answer. We have been the height. Now what we'll be doing here, we'll be doing here to find the area of the triangle CDB. So the area now, area of triangle CDB, we know that's half times base times height. If you look at above the triangle, the bases here is already 12 and the height we have already figured out just now by using the trigonometric ratio. So 1 by 2 times 12 with the base times height is 8.29. Now for solving it, we'll be get the answer for the area, that would be half times base times 8.29, that's in height. So the area for that is 49.74 meters square. Remember, the area is always in the squared unit. And we got the two areas of the both triangles. If we add them together, that would be the area of the total quadrilateral. So to add them, we'll write area of quadrilateral is equals to 49.74 add with 48.54. Now adding them both together, add with 48.54. So that would be 98.28 meters square. And that would be the final answer for this quadrilateral. So the area of the quadrilateral is 98.29. And the first part we have got the length of the area, that is 8.09. So make sure to subscribe and press the bell icon so you will be informed about the upcoming videos. We'll be covering different topics regarding GCSE. Okay then guys, see you then in the next video.